It's 1998, and I certainly don't know even what hard work looks like yet. Google was just getting started. I'm not sure Apple's web technology got much better than this. I definitely think they hit peak marketing here, though. Titanic also hit the box office that year. And Leo, here, about 25, is still older than most of his recent girlfriends. It was also the year that Tiger gifted us with the Furby, the first successful attempt at an interactive robot pet. The school playgrounds all over the world were a frenzy. It was all everyone was talking about in my school. And once the marketing was in full swing, lest we forget the Christmas riots of '99. And here Furby went on to sell 40 million units in 24 languages in the first 3 years alone. And this is impressive by any standards, especially with today, with viral marketing and how cheap marketing is these days. There's so much chaos going on in this scene, it's really easy to miss almost anything. There's no smartphones. Not a smartphone in sight. Like this cheeky chap going in for a sneaky self-serve. I also want to know what this guy's vibe is. I mean, being physically restrained in a children's toy shop is quite an achievement. That's a man that's been told to bring home a Furby for Christmas, or he's sleeping on the sofa. So thanks for coming, everybody. At this session, I'm going to share my journey reverse engineering the Furby. And I hope there'll be here something for everybody. I'll share the setup I used to explore Furby's capabilities. We'll dip into the original source code and see what the 90s called a learning machine. And I'll talk about Furby's best kept secret and what enabled it to become the toy of the millennium. So my name is McNeice, and with a mechatronics background, I started off developing FPGA technology for internet service providers at Nortel Networks. And as a graduate from university, I joined a software services company called McNeice and delivered some of the first ever B2B iOS apps for banks and hospitals. And now I lead engineering at a company called Hamilton Robinson. We're a mix of software and hardware engineers, working with customers like X, TikTok, Reddit, Datadog, Palantir. And some of our current enterprise projects are secure identity and right-to-work platform, check-in services for UK recruiting, air quality monitoring for the UK government departments that have to hold secure physical assets, and an IoT office space analytics product that helps companies manage their spaces. Some recent creative projects include digital interactives for science museums. There was one in Liverpool, and it was a touring exhibit called Our Place in Space. It was delivered by the UK children's author Oliver Jeffers. It was really cool. It was like a 13-kilometer walk with the solar system kind of laid out proportionally, and you got a really lovely sense of how far the planets were compared to each other, and there was an AR app that went with it, and we delivered that. And an interactive longbow, for example, that feels real at the Game of Thrones studio tour in Ireland. So I have a really strong belief that environments drive behavior. And where engineering teams have opportunities to develop both enterprise and creative applications is an effective way to hire and develop talent. So engineers, and I have this phrase that I try to use I call hyperstack, and it's kind of hyperstack engineers, and it's kind of like a play on full stack, where it's getting engineers, of course, to do full stack technology, but also to start learning enough about hardware and policy and business, enough so that they can communicate really effectively with other disciplines. So I'm sure you're all wondering, how did I get here? But here, for me, actually started in 2014. This is my son, Sam, here 3, And after a nostalgic garage sale find, my sister, still traumatized by jealous me continually hiding her Furby when we were younger, of course for maximum jump scare effect, brought one home. And naturally, Sam was pretty happy about that. We named him Frank. It was all going really well until I put batteries in him. Sam was terrified. So what is any father to do? At first, I thought, torch it, but saner heads prevailed. I took a walk to the bottom of the garden and dug out what tools that I needed and dissected the little demon. Frank, to be clear. And for Boy, watching this, it worked. Starting off a now long tradition of science and maker lessons at home. And yes, this is the torso of Hulk Hogan glued to a remote control car. It's a bit Toy Story Sid, isn't it? And of course, it was only once that Furby was in bits on my kitchen table that Sam leaned in and whispered, "You can't talk now, Frank." So wanting to grow that STEM spark, this got me thinking, what would it take to make Furby talk? I haven't been the only one to ask this question and other questions. So many people, of course, have seen the Furby organ. It was very, very popular a couple of years ago. A guy called Look Mum No Computer, and a handful of other things. Please, just if you just Google for weird Furby in Google, I'm not responsible. But I wasn't a fan of this model. It was something about the eyes. But the original one had potential. And I think it speaks to something really primal in us, that even basic eyes are almost all you need to start this sense of character presence. And with the original Furby having such expressive eyes, if it passes the meme test, it's all good. So I got started, and there was a prototype. And then there was lots of prototypes. And with each one of these, I was trying to figure out how to control individual components to maximize expression. Mouth, eyes, trying to integrate both of those. But it was very performance-led, much like a lot of engineers. And after a year of this, everybody was looking a bit worse for wear. And I was lost. So what does an engineer do when they're lost? Of course, they create a new JavaScript framework, but that didn't help here. So when I'm lost, I write documentation. And as it often does, it helps me step back and see the bigger picture. Why did we have to do any of this? Was it possible to keep Furby intact? It seemed like such an obvious question now. So let's change it up and have a look at the original source code. So this actually only leaked in 2018, so fair play to Tiger for keeping this secret for so long. It is 6502 assembly, which is very similar to the kind of Apple II code and kind of that instruction set that they were using at the time. But it's very well documented, 297 pages, which in fairness for assembly is not a lot. The one thing though that is missing is the speech chip firmware. So Furby was kind of one of the first generation of mature products that emerged there that was able to speak. And all of that firmware basically wasn't there. That's a Texas Instruments thing. They kept that secret. And Actually, one interesting thing to point out as well is this black resin, the little black dot you see on the circuit boards, was a really classic 90s artifact of security. So back then, we had no idea how to do chip security, never mind like decent IT security. And the way basically that the US in particular, but most of the world tried to defend itself against copycats, which at that point in time was coming out of China, that was basically to use hardware. And this was this really deep resin. You couldn't really get at what pins were there and what they were doing. And the only way to attack this was with this really dangerous acid or an X-ray machine, and it kind of just raised the security bar. So if you open up a 90s toy, you will see a lot of this. It's still kind of used, but not very much because security is cheap now, even on chips. So one of the things I mentioned was that the Texas Instrument hardware wasn't in there, but one of the things that this reminded me of, actually, if you've not seen this show, *Halt and Catch Fire*, if you haven't seen it, it is amazing, really good if you're a technical person and you have maybe a non-technical partner. It's a really great show to kind of give things for both. But in that show, there's a character that's introduced called Donna, and she's a kind of technical savant, and she effectively is building that Texas Instruments chip that ended up, I think, in Furby, or at least inspired by it. Would recommend. So I talked about how, at the time, it was called a learning machine, or this idea that it could learn. And a big part of the reason why they could say that was because it appeared to learn English from you, and that was the lore. And in the source code, I poured through all 297 pages of it, and honestly, I couldn't find any of that. It's not a surprise. But what I did find was very, very clever tricks to make people believe that it was. And one of the things that I came across was effectively just big tables of Furbish words, which I'll talk about in a second, and English words kind of mixed in. And as the tables kind of, table 1, table 2, table 3, and it kind of went on almost forever. And as those tables went down the page, more and more English words just started appearing. And effectively, as the thing got older, it just selected the next table and just happened to have more English words in its vocabulary. And there's a funny story, about this actually as well, in that Furby, Tiger, was actually sued for allowing a child to teach it how to swear. And they settled, actually, in court, but of course it wasn't true. But Tiger had a really interesting problem there, where if they had have come out and admitted that it wasn't doing that, it might have taken away a little bit of the magic. So they kind of just settled in court, and and to keep this magic alive, that Furby was learning English from you. So one interesting thing I came across was on first boot, Furby did a lot of work. There's a lot of code in there, basically to do an awful lot of work. And it probably was the second thing, I'll come to the first in a second, that was probably the most complicated part of trying to understand what it was doing. And effectively what it was doing, it was selecting a bunch of different presets or settings on first boot randomly. And random number generation at the time was really difficult, and I'll talk about that in a second. But it basically selected one of 3 pitches of voices, so you could have a deep voice, medium, and high voice. It also really interestingly seemed to weight the sensors, and for a long time I couldn't figure out why. So as an example, it has a light sensor, has a tilt sensor, has the ability for you to tickle its tummy, that you pat it on its head. And what was happening is it set up these weightings that either muted or boosted the sensor value that was coming and put it into memory and used that for the rest of its life. And what I realized after going through an awful lot of this and trying to figure out what the function was and constantly restarting it to put it into different personalities, was actually what this was doing was it created a Furby that was particularly tired or particularly wired. And it would respond quickly, or for example, there's a game, which I'll talk about in a second as well, hide and seek, where you would kind of cover the Furby's eye, and it would start this game of playing hide and seek with the child. And in those cases, it would either want to play that immediately, or it would maybe take a couple of goes. And you can see how that would affect this idea of this personality. I thought that was interesting. Also, a fairly simple one is that as it kind of grew older and it gained these different vocabulary and a few other features, it weighted the time clock on it. So sometimes the Furby would get older quicker, and sometimes the Furby would get older slower. And also, very importantly, for some of the game mechanics, it had this idea of getting bored. So whether you were playing with it or not, and how often you played with it and things, and it had a bunch of timers that was trying to keep track of that, and it weighted that too. So it was, again, changing its personality about how frustrated it maybe was with you or things like that. It was all very interesting. So I mentioned Furbish, and along with the toy came with this lore of what the Furby was and where it came from. The people who delivered Furby came up with its own language, a very simple language, but the names actually also were Furbish words. And you can see this is one of the tables from the assembly, and I think there was 25-ish here, and you can see that they actually were also Furbish. I thought that was kind of interesting. And again, it selected its name on first boot, and I think the names were like one or two of these, and they got extended with different Furby versions as well. One of the interesting things is I found a bug in the code, and really, and actually, instead of, they obviously didn't use source code at the time, it wasn't really very popular, so all of the comments for what the changes were being made were actually just comments in the code. It wasn't, tracking, GitHub updates or anything like that, commits. And this was really interesting because basically what this was, as I'm sure you can probably put together, is when the Furby woke up, that you needed to play with it or it got bored, and you needed to feed it or it got sick. But if you didn't feed it or you didn't play with it, it slowly got sicker and sicker and sicker. And eventually it got so sick that it refused to play with you. And you can see what happened there, that it effectively got stuck in this rut where if you left it for too long, your Furby kind of died, and the only way that you could recover it from the sickness was to reset the whole thing, and you had lost your progress and lost the personality, which is obviously pretty traumatic for some children. And this was patched, of course, but it's really rare. There's first generation of Furbies that have this bug, because what do updates mean for a toy like this in the 90s? You can't. So if you find one of the Furbies on eBay, and you find that it actually has this bug, they're very valuable. So they're probably retailing at 200, 300, 400, 500 quid. So the other interesting thing at the time in the playground when people were having these was, what did they get the Furby to do? And it played these. I mentioned a couple of games that it was playing, and there was some Easter eggs and some of these that I actually never heard about. So people had never came across, at least in my circles when I was younger. But in the code, they're all laid out, and I basically extracted them all out and put this little key. I think I'm the first one to do this. Not sure if that's a good thing or not. And you can see there's on the key on the left-hand side, that light is basically just like a light sensor, so it's kind of just in front of its eyes. Feed is basically, it's kind of like a button in its mouth, and you can kind of like push something in its mouth and it'll think it's feeding. Pet is basically a little sensor on its back. Tickle is a little sensor on its tummy. And noise, obviously, just a microphone, so it responds to noise as well, which was pretty novel at the time as well. And there's the sequences that you can put in. So one of the interesting things, a lot of these actually were fairly simple in terms of the code that was implemented these, except Simon Says. And Simon Says was almost 10% of the entire code base. So you can imagine the requirements for that just got out of control, and there was just edge cases everywhere. I mean, one of the things I remember reading in one of the comments in the Simon Says was there was comment after comment after comment, basically just trying to figure out why this won't work, and actually turned out to be the noise of the Furby operating itself was triggering the microphone, and that caused it to think that the child was responding to something, and that was a really difficult problem for the fix, very clearly. It was a very difficult problem for the fix, based on the comments. That you could feel the frustration in the code. And the other interesting one that I found was Twinkle Twinkle. Quite simple, but the very end of that game, it did something that none of the others didn't, and it ended up putting it into this weird state where you couldn't put it to sleep, and you couldn't wake the Furby up again unless you held it perfectly upside down, straight up. And I was scratching my head about, why did they do this? What is this? And then it kind of dawned on me, I had young kids at the time, and I was like, do you know what? Do you know what this is? This is a parental lock. This is, you give your kid the Furby, it takes it to bed, and it's haunting you all night every time the kid wakes up at night. But if you get into the routine of singing Twinkle, Twinkle to the Furby, it puts it in deep sleep, and the child maybe can't wake it up as easy. That's just my theory anyway. So changing gear again, I still wasn't satisfied with how Furby worked, understanding and how Tiger pulled this off. Because in 1998, you might also remember the Sonny Abito dog, and it was $3,000. And yeah, sure, it was probably small batch. They probably didn't have the opportunity to sell it mass market at that price. But Furby had so much emotional capability and motion. How did it do it for such a low price point? Something innovative happened here. And it was Furby's secret. And around this time, in my day job, I was working a lot on research and development for Kainos at the time, and working on a lot of computer vision. And I was spending a lot of my days trying to figure out how tracking was working and how to track objects. And while that's only probably emerging into a commodity now, it was really, really hard for a long time. So it kind of I had a little bit of bias, I guess, and it drew my attention. And I said, it must be something to do with like being able to track, and because where the motor is, and that was still really hard. And anyone who's worked on computer vision and tracking and things, they'll appreciate that how easy it is now and how hard it used to be. And of course, for mechanical systems, you can constrain them, so you can make them only go in one direction and things like that. It makes the problem easier, but it's still really difficult. So I started down that path. So in robotics and mechatronics and things like that, often you use two different terms for different kinds of tracking. One is called relative tracking, one's called absolute. Absolute is basically like the magic that we pretty much now have today, where you can put an object somewhere and some sensor or some camera basically knows exactly its distance away, exactly its orientation, and things like that. But relative tracking is a little bit easier, much cheaper to implement. And relative tracking basically means you can tell where it is relative to something else, but you actually globally don't know where that frame of reference is. And for some applications, that's okay. And what I noticed when I started looking at Furby was it had a really clever, very simple relative tracking system. So this is Furby in a very unflattering position with basically an endoscope up its bum. And this is like this little endoscope, and this is my iPhone running at, I'll play that video again, try and play that video again. This is my iPhone running in slow-mo mode, and it's still too fast to see the wheels turning. And this, I think it was like rotating at a ridiculous, there's a little hole basically on it. So the way this worked, as you can see, I tried to build a little schematic to kind of show it, is that there's a motor, obviously it spins, and it's connected to the face control of these different gears and things. But in between those different gears and the motor is basically a piece of plastic with a hole in it. And on one side of the hole, there's a light. On the other side of the hole, there's a sensor. And as that hole goes around, it can dark light, dark light, dark light, and it can count. And you can see that in this little video, if you can play that again. And just about, you can see that kind of dark patch that's kind of flying past the camera. And so, okay, find the relative part. The problem, as I said, with relative tracking is we know its direction and its displacement, but we don't know where it actually started. So at any point, did it start at 0? Did it start at 30? Did it start, and that's a problem, especially for something like this. So the problem with, so it's kind of like, and a good analogy for this is like, where the hands of the clocks are, but you don't know where the numbers are. And maybe it's a bad analogy because typically the 12 is always at the top, and that's intuitive to us. But imagine that wasn't a big assumption. We never knew where the numbers of the clock actually are. So we don't know really what time it is, but we know we can count minutes and seconds after that. So fixing that is called homing. And Furby, a 3D printer, for example, solves homing by when it first boots up. It typically you'll notice that it will just drive itself against the wall, and it'll bump something, and it'll detect that bump, and then it will kind of go, I'm home, I'm 0, I'm gonna count from now. And that's why, for example, if you bump a 3D, I wouldn't advise this, but if you put your hand in the way of a 3D printer while it's operating, it will either completely fail or detect that and go, sorry, I need to start again, and your print is now kind of broken. Some of the fancier printers can recover better, of course. But how Furby manages this is it basically, as part of that encoder, there's like a little notch that comes around and basically bumps a button. And cleverly, it actually does that on first boot. So as soon as you turn the Furby on, it will basically wake up, and it's because it's got not much memory, or at least not this kind of memory, that it kind of just drives forward. It turns out that that's its wake-up sequence, so it kind of goes and yawns, if anybody remembers it, and wakes up. And that's actually doing a full cycle of the gearbox, and bumps the button, and then it stops, and it's able to count from there. So now we've got the numbers of the clock. So what was my experimental setup as I started to kind of play with these capabilities? And I'm not going to spend too long on this slide. Certainly, if you want to talk about any of these parts, the parts that I use, happy to chat after. The only highlight that I would probably give is that I really love the Teensy set of microcontrollers, simply because they're really fast for how cheap they are. And you can do there's lots and lots and lots of capabilities, including, for example, being able to, nothing to do with Furby, but being able to do both USB host and client at the same, even at the same time. And what that means is you could do a lot of really evil things by simulating or appearing or spoofing to be another device to any other device over USB. And you can do a lot of really evil things with those. So I use Teensies because they're fast, and they've got loads of really interesting features. If we add all that together, fingers crossed for a live demo. Let's see. That we can get things like, I can get it to blink. Oh, is my video gone? I think my video is frozen. That's unusual. Okay, let's try that. And it's going to end that show. And I'm going to try camera format, camera preview, make sure, try that. Hello. And try that. So let's try that again. Try and get all these things up on the screen at the same time. Oh, that's interesting, isn't it? That didn't happen earlier. Okay, I can probably do that another way. I'll see if I can change. I'll use the photo booth and see if that works. There we go. So we can get it to blink. We can get it to wiggle its ears. And of course, we can get it to move its mouth. Nom, nom, nom. And one of the things of different expressions, of course, like surprise, and my son's personal favorite, suspicious. So, play from current slide. Does that work again? Okay. So it turned out that the real secret to Furby was inside it the whole time. And it had to be this. It had to be whatever this little white sandwich was. It was the only kind of problem that I hadn't really looked at yet. but I could never imagine anything like this. And that little sandwich that you've seen basically was this sandwich of little mechanical marvels. And effectively what this was an entirely mechanical, analog state machine. And you can see with these different circular ones, they're a wee bit like clocks. And the motion, 2D motion, so that's kind of out and often in with levers. And of course, the timing of when that happened is encoded into each of these little kind of clock faces. And as the motor is driving it round and round, all of these kind of clocks turn and they all interact with each other in really interesting, novel ways. The bigger pieces are actuators, so that's usually connected like a little pin into the wheel, and as it kind of follows the groove of that kind of clock, that basically does something. And what this also meant, of course, that all of the motions that Furby can do was predetermined. It wasn't like it could blink on its own or move its mouth on its own. It had to do them kind of all in this orchestration, all at once. And actually it was the clever part about putting it all together in a sensible way was really about tracking. It was really about figuring out where the gearbox was at the time and figuring out where you wanted to get to and keep changing gears or changing direction and things like that. And I have a little diagram here where I was starting to kind of map those out and trying to figure that out.
Hey, Luke, I didn't know there would be so many people here. I'm so embarrassed.
Now, Siobhan, you told me that you weren't going to interrupt my presentation. Please, just let me finish, and then we can talk.
Yeah, but I don't get out much.
I know. I feel a little bit sorry for her. She stays in a black box most of the time, and I only bring her out at conferences, and there's always lots of people, and everybody's very caffeinated. But please, promise me.
Uh-huh.
I wasn't too sure, but that didn't sound like a good uh-huh. So, sorry about that. Let me continue. So what I was trying to say...
This is my chance? I knew I would be a singer. Ba, ba, black sheep. Have you any wool? Yes, sir. Yes, sir. 3 bags full.
She's a big showman. No, I'm going to do it.
No, Luke, not the dark. I don't like the dark.
This is how you put her to sleep. It's one of the mechanics. One of the mechanics, as I was saying, it's one of the games. So that's the original Furby audio for when Furby fell asleep. That's it, I promise. So this Furby, this design that you just seen, is my 4th version. And it's a very performance-led design, probably unlike what I was talking about, putting it all together. It was almost part of the story to have you all believe that maybe it couldn't do as much. I'm just going to take her skin off. She looks a little bit different with her skin off. Let me see if I can get that. Oh. Photo booth. So. And you can see that most of the Furby, actually the only original part from this version of Furby is actually just her face. Thank you. Let me just end that. Will that help? Photo booth? There we go. So the original part, as I was saying, she's asleep at the minute, but is just the face. And all of the kind of the rest of this version of Furby is entirely custom, all 3D printed. Of course, I'll talk about that in a second. And I'm using this like Bowden cable design, where basically almost like a little umbilical cord with fishing wire, which I'll show you the details in a second. And I have this big, bulky, noisy actuator block at the bottom, which I'll show you a few more bits in a minute. Not all the Furbies. My fourth version is like this. A lot of them I try to use the original parts more and just ran into lots of limitations. I'm also going to put her in a slightly better position. So, okay. Slideshow, play from current slide. So how I made all of this work was teensy, same microcontroller, but also I moved all of the motion control to an external device, and I'll talk a bit about why I did that in a minute. That device is called the Pololu Maestro. I discovered it when I started getting obsessed with, probably like many people here, the Disney Research YouTube channel, where they were kind of doing really deep research on how to build effectively robotics for kids and put them in the Disney parks, and how to basically take really heavy things and make them really small and really light. And a lot of the work that they were doing was based on this Pololu controller, but also there was a lot of boating cable design, so basically fishing wire or something else somewhere was kind of pulling cables, and the actual device, the business end of the device had springs and elastics and things like that. How I got her to speak was another external device called an MP3 trigger, but just because handling audio in a microcontroller is really difficult and takes an awful lot of resources, so externalizing that made sense. And then how I do the remote control, so I was controlling her basically with a little Bluetooth controller, is using a processing IDE, so basically like a Java application that's, I'll show you in a second, just for basic UIs, and it's really good for integration with external devices and accessories and serial ports and things like that, usually for quick and dirty things. And the voice came from 11 Labs. I'm sure everybody is aware of that service these days. So the CAD model looks, the CAD model looks something like this, and usually it animates. Let me see, can I drag it? No, I can't. So you can see there that all 3D printed, and most of the parts are all in layers. So you can see here, this is just basically like a mating interface to connect it to the tripods and things like this. This is like a chin piece, again, just to like bolt the face on. It also holds like some of the boating cables at the back. This is the mouth actuator, which was probably one of the more difficult parts of the Furby to get working well. Probably with version 4, it was probably the biggest shift because it wasn't very reliable, didn't travel well. So basically I was turning up to demos, doing these things, and the demo didn't work, and it was very disappointing. But managed to do a lot reliably, and then this kind of top piece basically manages the eyelids, the eyes, and the ear, and allows the ears to work as well. The actuator block that I showed you there is just done on the floor here, and it looks complicated, but it's not, and it's a monstrosity of like basically mechanical technical debt, and it basically just holds a bunch of servos, very simple, and fishing wire basically comes through little tubes, and it kind of pulls them, and it allows me to take a lot of the mass basically away from the face, a lot of the weight, a lot of the, has opportunities to make it quieter and those kinds of things, which is obviously really beneficial for something like this. And as I said, it uses fishing wire and springs, and you can see the kind of two major components, and it kind of, as long as you've got a strong pull from the actuator block, and it kind of light, so when it lets go, and it's not pulling the fishing wire anymore, that the face itself can kind of return to kind of a neutral pose. That was important. The reason I mentioned a few times, but the reason why I went cable-driven is because I can relocate basically all of the hard stuff. A few of the earlier Furbies, I tried to fit all of the actuators in here, and it was just big and bulky and heavy. It was hard to hide, lost the magic, and also had a lot of complexity just because I was trying to pack everything in. But there are some cons, of course, to doing cable-driven. But just to zoom out, I think about robotics a lot, probably mostly to do with my degree and tinkering with Furbies like this. And one of the things I wanted to take the opportunity to mention is that there's a big shift coming. And I wanted to talk about why. And basically one of the reports that I think is quite useful for almost any future product. So if there's something that seems far away and seems expensive and it's not quite ready yet, one really easy thing that you can do is basically list out all of the components, virtual, software, hardware, whatever it happens to be. You list them all out and sort them by price and find the single component that is the most expensive and just track that over time. And what I've noticed that when you do that for almost anything, you can see when the disruption is going to happen. You can see, because you usually just see this thing and then you see this sharp drop and something has caused that. And then usually what happens is you get this kind of 18 months later, you start to see the DIY community, the maker community playing with it. And then 18 months later after that, you usually see the first companies coming out with like relatively still expensive prototypes. And then 18 months after that, you see again this huge drop with like commercial products. And one of the basically inflection points for this that's going to kick this off was the MIT open source planetary gear actuator that was in the mini cheetah. You might have seen it. It was maybe 2018. Little mini robot dog looking thing, and it was basically running around. It could go really fast, and they managed to produce that for $10K. It seems expensive, but compared to its kind of grandfathers, that was nothing. Then what basically happened is I think that the Chinese and the Koreans basically figured out how to take that and apply it to real products the fastest. And in 2021, Zomi came out with the Cyberdog, and Unitree came out with the Go 1, and you can see they're got all the way down to 3K, 2.5K. And then what's also happened, and I think what a big Reddit thread was quite interested on this and kind of claimed that what was happening, that Zomi basically had a lot of really interesting engineers, really talented engineers, and they'd stay to deliver the Cyberdog product. And then after they'd done that, they effectively left and then realized that something was coming and built their own actuators. And these started appearing then on Alibaba and things like this. And the first high quality planetary gear actuator appeared called the Cyber Gear. And it got all the way down to $60. And wind the clock back 10 years, these things were $6,000, anything from $6,000 for a terrible one, for something that was really light, all the way up to 50 or 60 grand for heavier ones. And but you can see that the price drop is kind of continuing to go there. And this is the key unlock for the robots that are about to explode, basically in the next couple of years. So just jumping out of that, so the control and coordination, so schematically, talked about all of these components, but we've got basically the brain, the controller, the orchestration, all happens on this little microcontroller. The Pololo Maestro is basically the thing that manages all the servos and all of the motion, and the really good thing about that is all the motion paths and where the servos need to be at certain times takes a lot of resources to compute, and basically making the teensy busy doing all of that makes it really difficult to do anything else. On microcontrollers, threading is hard. You usually only have a single thread, so you can very, very easily fall into this trap of trying to compute, I don't know, what a servo angle needs to go from here to here and the timing of it and things, and then all of a sudden you lose the ability to capture an API request coming in or something like that. So I outsourced that to Pololo Maestro, and it was awesome. And then I mentioned the MP3 trigger module, which is connected to a speaker. And then I have the processing application running on a Steam Deck, just running Windows, just at my feet here. So as you can imagine, this was a integration nightmare. And most of the kind of communication happens over UART, which is a hardware serial. So examples of hardware serials, if you're familiar. Does anybody do embedded electronics? Awesome. So examples of hardware serials are UART, SPI, I2C, CAN. CAN's often well known because it's in cars. So CAN bus, for example. LIN is a cool, very simple one that I really love. Different features and decisions that you want to think about when you're choosing these does it allow single devices to communicate? Does it allow multiple devices to communicate? Some of these are relatively slow. Some of these are blazing fast. These are the things inside the hardware that we have that does 4K cameras or high-speed cameras, or they're really, really competent. And or whether you buy modules. So if you're building something like a Furby and you want to add another capability, maybe it's not something you want to spend time on. You just want to buy something off the shelf. What protocol does that support? And basically a lot of off-the-shelf modules would increasingly support I2C, and UART has kind of always been around. It's also super, super fast, but I2C's got very, very popular. And noise resilience, and that's one of the things that I found, like as a junior coming to this, that I just didn't know, didn't respect, and got burned many times. But basically a lot of these serial protocols don't survive long cables. And actually what's happening there is, no joke, that cosmic rays from space or the microwave in your kitchen or something literally just spraying out RF energy and literally turning a 0 to a 1, poof, bang through the wire. And it's really, really hard to find those bugs. You think they're bugs, but they're not. It's actually this. So a lot of these cables have to be very small. There are ways you can kind of fix it, but it's obviously a very punishing lesson when you start doing this. The way to think about hardware serials is it's a bit like an API, but there's a few extra steps. So often you have to handshake with the device. So often it's like you have to tell a device a secret password, or often you have to configure some registers or something on it first to kind of set up a configuration. You also have to kind of pack the data that you want yourself in the orders yourself, and you have to check the data sheets, and it's very functional and strict. You also have to deal with buffers. So for example, when information is coming in, you have to kind of fill it up until it gets to a certain level, and then you would basically go back and get that. And you can have lots of challenges around whether or not the thing talking to you is faster than you and things like that. And encryption is like the Wild West. Basically, generally speaking, in hardware, it's not done. And what that really means, and it's interesting, is that if you open up a device, including things like planes, and you just get access to the copper on the PCB, you can see exactly what it's doing, and you can control it, and it won't even know. Wild. So I mentioned about embedded threading. It's really challenging on embedded microcontrollers, and the way that I have learned to solve this problem, it's easy, of course, in modern computing. You just throw more threads at it, throw more resources at it. There's libraries to deal with that for you, queues, those kind of things. But for embedded, it's not as mature. It's not as easy for many different reasons to implement those things. And the way I do that is basically to use what is called a scheduler. And you can do it on a single thread, and it's basically a library that effectively parcels off bits of code or blocks of functions that you want and abstracts them away. Usually it's done at a machine code level, so it's kind of abstracted away from you. You don't really know when it is, but it basically puts it in a queue, and the library effectively manages that queue and reorders it for you. And a lot of these schedulers allow for priority, so you can see where different aspects of Furby need done in real time, or different aspects of Furby doesn't really matter. So if an event happens, I can reschedule that and things like that. Auto pause and resume, which is again like a poor man's threading. So if a function is running, but a high priority thing comes in, it can just literally pause that code at this, the processor level, and just jump out and start executing another code. And when that block is finished, because it's high priority, it'll just jump back and resume while keeping all of the whatever the function memory was at the time, and it kind of loads that back in. Timeout and watchdogs. So if something's taking too long, boot it out, or whatever behavior that you want. And most schedulers support multi-threading if that's available to you. TNC4 doesn't officially formally have multi-threading, but it does have this dual issue superscaler, as it's called. It's a bit of a mouthful, and it's kind of a fancy way of saying it can execute two things at once, which is kind of, again, like another per man's multi-threaded. I mentioned about the Polulu servo controller. This was awesome. Found this being used by some of the Disney research engineers, but it's really weird, and it's really unintuitive to learn, very sharp learning curve. And it has this really weird kind of like stack based approach where you have this global stack that you have to push variables into, and you can run like a small instruction set, but you never actually directly pass those functions like variables, and they just automatically go to the stack, and most of the operations you have is really about changing the orders of the stack. And I find it very complicated to get started, but there is a nice elegance to it, but it's pretty cheap for what it does. It's pretty robust, And the only thing it doesn't do that's really frustrating is it doesn't have a random number generator. And one of the things that it was important for Furby is to do what's called idle. So idle just basically means, just going to cancel that, press the wrong button. Yes, there we go. So idle basically means look like you're real by not doing very much, and you need random numbers, of course, to be able to do a function like that, and I couldn't do that with a Polulu, and it ended up being an integration nightmare, because what I ended up having to do that was effectively get the Polulu controller to kind of ask the teensy or try this first to get a random number, to then give it back, and it just ended up too complicated. And I basically, for the idle, I actually outsourced the entire thing back to the teensy, so it basically just directly tells the Polulu controller what to do, and it does actually do the thing that I said I didn't want to do. And it was the only way to do it. So certainly if anyone from Polulu watches this video, please, random number generator, that would be awesome. So I mentioned about the dashboard and remote control. I use the processing IDE. It's kind of Java-based. Feels really filthy on my tongue. And it's really fast to develop UIs, really easy USB integration. It is a bit flaky sometimes in the kind of when the computer restarts or you keep restarting the application and it kind of holds on to the handlers and tricks you into thinking the USB is not available when it is and stuff like that. And Bluetooth is really, really easy. So you can get basically something that's basic looking but functional and integrates with hardware in an hour easily. So what's next for Furby? For me, at the minute, I'm really focused on trying to make it more reliable. This is probably the 4th or 5th time that I've done similar talk with similar demos. And as I said, it doesn't travel well. Very, very difficult to take in a plane and reset up. And I had a very nervous 20-minute handover from the last speakers that was cut a little bit short. And so for anyone that was kind of in the room early, they would have seen me sweating. But also, like there's a lot of cabling that I want to improve. But I also have had a lot of requests to deploy this into effectively like events and exhibitions and things like that. And leaving this kind of where maybe the public can do anything with it. Maybe you could put a glass box to physically control it, but would be awesome. And so I want to be able to do presence detection. So really simple, just is someone there and kind of like start functions and things like that. But then ultimately another phase would be, can we make it conversational? So a lot of the behind the scenes, a lot of the voices there was scripted, and you probably noticed. But there's no reason why with some of the AI products that we have now that you can get real-time voice out of that and real-time transcription as well. So maybe be back next year with that. Thank you for listening. I probably don't have as much time for questions as I thought. Thank you for staying so late in the conference for a talk. It's always hard. I'll be kicking around for probably the next kind of half an hour, just grabbing coffee or whatever if anybody wants to chat about anything. Thank you for listening.